Hi, today we want to learn about pendulum in N and O level physics. So what do we need to know for pendulum? Now a pendulum is something that has a feet support on top, and then anything that suspend from a light string, alright, and able to swing freely, we call it a pendulum. So like for example, let's say I have a simple pendulum here. So as long as it can swing independently, alright, from a feet support, alright, this is called a pendulum. Alright, so that is a simple pendulum. Now the length of the pendulum is from the feet support until the center of gravity of the bob. This is called a bob. Alright, B-O-B. So this is called the length. Alright, usually denoted by L. Now, it is not easy to find the time taken for it to swing one complete oscillation. Now we call that the period, which is the time for the duration for one complete swing or one complete oscillation. Now, so usually we'll take the timing for it to swing 20 oscillation. So we use a stopwatch to time, say, okay, 1, 2, 3, 4, 18, 19, 20. So with the help of a stopwatch, suppose let's give a simple example. We measure 20 oscillation and found that it is 16.0 second. So therefore, one oscillation will be 0.8 second. Alright, divided by 20. Okay, we get 0.8 second, which means for it to swing from the extreme position to the next extreme position and back, it takes 0.8 second. Alright, now suppose, okay, this is called the period or periodic time of the pendulum. Suppose if we swing between A, B, which is a rest position, and C. So from A to B, alright, it will take 0.2 second. And then it swing from B to C, it will take 0.2 second. And then C back to B, right, backwards, another 0.2 second. And then B back to A, and then that will be another 0.2 second. Now this complete cycle, one oscillation, is what we call the period, which is 0.8 second. Now also note that the beginning point need not be A. You can start from B, 1 quarter, 1 quarter, 1 quarter, 1 quarter, or you can start from C, 1 quarter, 1 quarter, 1 quarter, 1 quarter. So this is about the periodic time of pendulum. Now next, we need to know if we change the length of the pendulum L. Alright, if the length of the pendulum increase, alright, it would mean that the periodic time will also increase, which means that it swings slower. So the reverse is true. If it's a shorter pendulum, you swing faster and have a smaller periodic time. However, alright, the period of the pendulum is independent, which means it does not depend on the mass. It does not depend on the mass of the bulb. Alright, counter to our intuition, even if we change this mass to a heavier bulb, alright, with the same size. Now if we neglect air resistance, the periodic time of the pendulum only depend on the length and not the mass, which means that whether I use 20 gram or 200 gram, alright, for the bulb, the periodic time will be the same. So in summary, we need to know that the period is the time for one cycle, alright, and the pendulum periodic time, the period depends on the length, and it does not depend on the mass of the bulb. It does not depend on the mass of the bulb. Alright, thank you for watching.